Right, so our last section is section 5.6, and it is the inverse of a function. So remember, y is just a fancy name for f of x. So in this textbook, you see it both ways. So our first example is let f of x equal 3x minus 5. And a solve y equals f of x for x. So what we're saying then is we're going to say y is equal to 3x minus 5, all right? So now we're going to solve it for this x, all right? So we're going to undo everything and move it over to the y so we get the x by itself. So remember, first thing we're going to do there is we're going to add 5. So we'll get y plus 5 is equal to 3x. And then to get x by itself, it has 3 times x, so we know we are going to go and divide both sides by 3. So if we do that, we'll get that x is equal to y plus 5 divided by 3. And then part B asks us to find out what the output is, what the input is when the output is negative 11. So again, our y is still our output. So now we're just going to say x is equal to negative 11 plus 5, all of that divided by 3. So again, negative 6 divided by 3, or x is equal to negative 2. All right, so we undid everything. And functions that undo each other are called inverse functions. You can use the equation solve for x to write the inverse of f by switching the roles of x and y. So we actually did that on the first example. Now we're going to do it more formally. So find the inverse of f of x is equal to 2x plus 8. Step 1, replace f of x with y in the original equation. So if they don't have f of x, sometimes they will, sometimes they won't. Again, you're just going to use the y. But in this case, they did start us with f of x, so we're going to replace that with y. And then we're going to do kind of what we just did up above. Except this time it's telling us instead of doing it that way, we're going to interchange the x and the y. So x is equal to 2y plus 8. So now they're telling us to solve for that y. All right? So when we solve for that y, we'll get 2y is equal to x minus 8. And then I can take and divide everything by 2. So I'll get x minus 8 divided by 2. And now it's saying we're going to replace this new y, because this is a new y. It's not the same y that we just had. We're going to replace it with g of x. So we started with f of x. All right. And since we did the inverse, we need to have something different. And your book chooses g of x. So we're going to say g of x is equal to x minus 8 divided by 2. Or, again, you can divide both elements by 2, so we could get 1/2 x, and then negative 8 divided by 2 is 4. So I'm sure your textbook will take, your platform Big Ideas Online will probably take either one of those. Right, so now we're going to do the same thing, but we're going to learn how to graph it too. So the graph of an inverse function is a reflection of the graph of the original equation over the line y is equal to x. So I'm going to go ahead and draw that. Remember, when x equals 1, y equals 1, x equals 2, y equals 2, and so on. Negative 1, negative 1, negative 2, negative 2. So there's your line y is equal to x. So we're going to use that, so I probably should change my colors here. So the graph of the inverse function is a reflection of the graph of the original function over the line y is equal to x. So we're going to find the inverse of the equation f of x is equal to x squared minus 2. And again, we're going to keep it where x is greater than 0. All right, so now if you think about it here, we know that, let's go ahead and graph this one here. So when it's at 0, we know it's going to be at -2. Okay, you could always draw a t-table if you want. Let's see, when it's at 1, it'll be -1. When it's at 2, it'll be at 2. All right, and you know, so we know it's going to kind of go like this. And you could do some more. All right, so that's our f of x. All right, now we're going to do our inverse. So we're going to find our inverses. So step 1. All right, we're going to take our, and what I just told you, we're going to replace f of x with y. Then step 2, we're going to exchange the x and the y. Okay, and then step 3, we're going to solve for this new y. So then we'll get y squared is equal to x plus 2. And then I'll get y is equal to the square root of x plus 2. Now let me put a little note there for you. Because remember, I always tell you, we're in algebra 2 now, we should say plus or minus, but I didn't say plus or minus this time because we were told that x is greater than or equal to 0. Okay, so that's why I didn't do that. And then the final step, step 4, was to replace our new y with g of x. All right, and now we're going to graph that one there, and we're going to kind of see. So remember, when I'm looking at a reflection over the x-axis, and let me see, why don't we go, I'll go green. Remember, I can go to the line of reflection. So if I go over 1, 2, I'll go up 1, 2. So that should make sense, right? And then when it was 1, again, I can go over 1, 2. Go up 1, 2. And you can plug those in, ladies and gentlemen. You would see that it is actually right, okay? When x is equal to -1, -1 plus 2 is 1. So we know that one's right. And then again, the same would be for the other one we would have here. So here's what our g of x looks like. And it is a reflection. So you could even graph those on your Desmos and see that we would still get the same thing, okay? So here, let me go ahead and get rid of that part. Right? And of course, this one right here was on the line of reflection, so it just stayed there. All right, and our last one is you can use the graph of a function f to determine whether the inverse of f is a function by applying the horizontal line test. So what they're saying here is, you know it's a function because they drew a horizontal line and it went through the function only once, right? Remember, we know that for anything. So on this one right here, when they did the horizontal line test, well, it went through a point here and this point here, and it's only supposed to go through it once. So we know that that one is not a function, all right? So our last example here, example 5, consider the function f of x is equal to 3 times the square root of x plus 4. determine whether the inverse of f is a function, then find the inverse. All right? So on something like this, you would plug it into your calculator. And I'm just going to tell you right now, for the sake of time, it is a function. All right? So we're going to go ahead and do like we said before. So we're going to step one. Oops, let's put our pencil. So step one, we're going to change y with f of x. I think your textbook starts with y, actually, to be honest, but there's ones who tell you to do this. Step two, change the x and the y. Step three, want to exchange them, so we're going to take and we're going to divide by 3, so well, the square root of y plus 4 is equal to x divided by 3. Again, how do you get rid of a square root? You square it, so we have to square both sides. If we do that, then we'll get y plus 4 is equal to, again, we're going to square the x. We're going to square the 3, which is 9. And then we're going to solve. We'll get y is equal to x squared over 9 minus 4. So now we have the y by itself. And then the final step, and replace that new y with g of x. And we can write this as 1/9 x squared, which is the same thing as x squared over 9, people, minus 4. All right? Now they're going to want to know what to say our domain is. All right? So let's go ahead and look at this, and I'm going to tell you off to the side. So because, and remember on this one, you have to think about the range because that's what our y was. But on our new one, it's going to be our x. All right, so because range, in this one here, we know our range has to be y is greater than 0, right? Because we can't have anything else. So, since we know that, so the domain of g of x must be restricted to, so since we said y is greater than 0, remember here it's now it's our x. So x has to be greater than or equal to 0. Because remember, this was our range, but when we did the inverse, it now became our x. And that's why it has to be our domain. All right.